Hi friends, myself Dr. Dev Sava. I am working as an assistant professor in SR University, and this is my sixth number of lecture on part of DC generator. Come to the point, the sixth lecture is classification and application of DC generator. Here we will understand about the types of the DC generator and what are these applications where we can apply these DC generators. Now point is classification. How will classification will do? Then when the classification comes to the picture, it depends upon the energy supply, how we are energizing the generator. Actually, in a DC generator, there is two parts are very important. One is your field winding and another one is your armature winding. Okay. And we already discussed more about in the construction what is field winding, what is armature winding, and where it will place. Everything we already discussed. Now, point is if I am giving two different supplies, suppose I am giving a supply to field winding and I am giving another supply to armature winding, that is based upon this supply, we can say if different supply is there or different supply is there, supply to energize the generator, it is equal to your, you can say one of the type that is separately excited. Means we are giving both are different excitations. Okay, this is one point. Another one is your self-excitation. Self-excitation means we are giving same supply to both field as well as armature, both field and armature. Okay, and you can see that is known as your self-excitation. Then based upon the supply, what will happen? One come is your separately excited and one is your self-excitation. You can see here self-excitation and separately excitation. Detail about this process or detail about these types will discuss in the next slides. But first we understand two types came. Okay. But what happened again? Self-excitation is divided into three more types. That is your shunt generator means both the connection of field and armature is parallel. And the series generator, here both the connections of field as well as armature is in series. Then compound generator, it based upon the field arrangement. If there is a compound generator, more we will discuss. But the compound generator, what is the difference here? Here, according to the field arrangements, we can decide how it is compound. And in addition to the field excitation and armature excitation or armature winding, field winding, then one another winding, series winding is required to develop this compound generator. And this is also further divided into two parts. One is your long sum generator, another one is short sum generator. We'll discuss the next slides. First, we'll discuss about the separately excitation or separately excited generator. Then first you see the circuit diagram. In this, you see, already we know that in separately excited generator, both are having different supply. Means both are different winding as well as different supply. If you will see this black line, then what will happen if I will mark in a something different color? You see, in black line, you see the current is suppose entering to this part. Okay, and this red is current is entering plus field winding. I'm explaining current is going here, here. current return path is here, and again current is returning path. If it will start from A, it will return to B, right? And how the current will go? Here we are giving one supply. That is here you can say VAC, the supply voltage we are giving. Okay, due to the supply voltage, your armature winding is energized, and this armature will generate some EMF, that is your generated EMF. Now I am indicating different color, the current direction. Due to the generated EMF, we can put here, that is your process V1 and V2. The current is going like this, right? And we can connect the armature terminal here. You can put here armature terminal, that is your IA, and we know that we are connecting the load to the armature. That means here the load we can connect, right? This is all about our construction. Both are having different supply, different connections. And if the conductor is winding like this, then denote these conductors there, because conductors are definitely having some resistance, and we can denote this one is your field resistance because it is connected in field. Similarly, armature winding also contains some conductor, and we can denote this as an armature resistance. Now come to this picture. It is simplification picture. What I mentioned, that is field resistance. Here it will contain armature resistance, and here it is your generated EMF. Then D2 cross 1 and cross 2 voltage drop will occur, and we are giving a supply, that is your supply voltage. We are giving to the field winding, and here it is the armature winding. We are connecting the load. This is all about your separately excited generator. Now, if this is our separately excited generator, the circuit slightly modified by adding this variable resistances, because variable resistances is added to vary the speed or to vary the voltage level, by which we can regulate the voltage, and according to our requirement we can use. That's why one variable resistor is connected is in series. You can write here that RF is nothing but capital RF, that is nothing but your variable resistor. Okay. Then come to the next. What is that? That is your R small RF, that is your fixed resistance. Then what is IF? IF is your field current or field current. Okay. And as per the connection of parallel or series, you can also rename as this one. But this is known as your field current. And what is your VAC? VAC is your supply DC voltage. This part is over, like this is the part of field winding part. Okay, don't confuse. But you understand the each terminology, then we will discuss the field winding. Then come to the armature. Armature, what are the parts? See first. First, write down the parts. Armature winding is there, means I already mentioned there is a resistance, that is your armature resistance. Okay. Then Then the next part is your current IA. IA is also nothing but the armature current, same armature current, right? Then come to the EG. EG is the generated EMF, and it is depend upon the field winding, right? EMF. Okay. Now load current. This is your load current. But one point you see, if you compare this armature current and load current, you see both are in the same, because same current is flowing, okay, across the armature and load. Then one point you keep in mind, In separately excited generator, IA equal to IL. Then another very important thing, 2 points are there. We know that armature is connected with the brushes B1 and B2. Then each brush capacity means maximum resistance or opposition is 1 volt. Okay. Then you can make it as a voltage drop across the brush. You can write here voltage drop across the brush. Drop across the brush. How much? That you can write equally 2 volt. And it is constant for all the cases. Two brushes means if one armature is there, then definitely two brushes are there, and the constant voltage drop is 2 volt. During the equation development and everything, also it is required. Okay. Otherwise, if you are neglecting this one, then okay. If it in the question it is not asked, means you can neglect. Okay. But if you remember, also it is good, and you can put in the question also. Now come to the derivations. How we will compute the armature current, field current with this circuit diagram. Now, separately excited DC generator, already the parts we discussed, and you see there is two loops is formation. One is your this side and another one is your armature windings. You can put here that A, and here you can put B. First we will consider the field winding part. Then you can write apply KVL to field windings. Okay. Then you can easily write the equation for this one. I'm just changing the color for you. You see the equation, what will be there? The supply voltage V minus, due to the V, what will happen? You know how the current will flow across the circuit. If I will go, this is the clockwise direction, then the equation becomes the field current IF into RF minus, that is your IF into small RF, right, is equal to 0. So the sum of all the voltages are 0. It tells about the KV. Now come to the point how we will calculate this field current. And if see from this equation, if we derive the field current, then can I write that IF, because IF is common in this RF plus small RF variable resistance plus the fixed resistance equal to. Now I'm solving the equations. Then you can easily see here IF equal to V by RF plus, okay, you can mark it as a equation number 1. Okay. In this equation, I think no doubt will be there. It is very simple equation, so derive this one. Then come to the armature winding. Armature winding to calculate the armature current. You can mention here we are calculating armature current in field winding, that is the field current. Now similarly we will apply KVL. Then apply KVL means what we are getting, you see the equation, that is your generated EMF EG minus, we can write the gross voltage drop. You can write here, that is gross voltage drop PV minus again. And we know that armature having some resistance RA minus RA. Okay, is equal to the load voltage. Right? All the voltages are there equal to the load voltage. Then what will happen? If you want to calculate this IA, then can I write IA array equal to nothing but your generated EMF minus cost of voltage minus VL by means if you calculate IA, put as a equation number 2. This is one of the formula. This is one of the formula, and another formula already in the previous slide we discussed that in this case IA equal to L and all the relations load current also equal to the armature current. This is all about the separately excited DC generator. I think it is clear for you now how the design happened and what are the field current, how to calculate field current and armature current. Now come to the applications. First, as we are using the variable resistance, it is used to speed control. Okay, because if you will vary the resistance, the variable resistance you are adding, then definitely by giving the field supply, you can vary the resistor, and by varying the resistor, you can also regulate the speed. And we know that in a laboratory also different type of generator testings are there. Okay. But in laboratory testing, what will happen due to the different test conditions, so that definitely the voltage levels are different. For that reason also, this separately excited generators are preferable. Okay. And if you need the stable DC supply, for the motors also, it can be used as it can be provide the reliable supply under variable field excitations. If we are giving the different voltage also, it can give the stable DC supply for motor operation. Okay, due to the variable resistance. These are the three important applications. It can be used for the separately excited generator. Now come to the second type, because we already discussed about separately excited. Then come to the self excitation. Self excitation, already I mentioned that both field and armature having one supply. Then come to the next, and it in self excitation there are three parts. The first part we will discuss, that is your Shunt generator. Then come to the first, we will see how it is the connection diagram. Then we will go detail. You see here, you see both the supplies are having the, suppose we are connecting here the load, here connecting the suppose this color, then I'm connecting your load or any source. What will happen? Generated EMF, the current here, the current will go like this, and here the current is divided into field windings. You see the field winding, the current is coming, it is coming, then it will again merge. And what will happen in armature winding? It will go like this, and here it will come. Then again it will return. Okay, that is means you see. Uh, Initially, the armature current will be like this IA, and this is your, you can say, field current, or it is connected in shunt means you can also say shunt. You can write everything. Then here it is going to the load, right? You can write here IA equal to ISH plus IL. Then the direction will come here. Load current is reached in that point, and ISH will reach in this red line ISH. Then we know that ISH plus IL is equal to your A. Again it will enter to this armature. That means this is the whole current directions how it will happen. If you want to see here also, you can, I will redraw for you. You just see here, I am connecting a load across here. Okay. Now, generated EMF it means suppose we are giving a supply and your armature start generating. Okay, armature is generated some EMF, and due to the EMF, this is the armature current will flow. And we know that this is, if this, as this armature and field is connected in parallel and load also connected in parallel, what will happen here at this point? What will happen? The current will divide. One part it will go in the field winding side, that is shunt current, and one part it will go to the load. That you can, we know that if you will put some point here, that is, see, the incoming current is equal to the sum of the outgoing current. Now the IL will come here. and the shunt current is coming here, and both are adding up, and it will enter to the armature. If you will make this is a 2 points A and B, that means every point it is clear that your IA armature current equal to your shunt current plus load current. This is the thing. And our KCL also, A and B point, the KCL is proved. Means the incoming current to the point A is equal to the sum of the outgoing current. Here, now we will detail, you will understand the equations as well as the relations also. Here, don't be confused that RSH, you can write that shunt resistance, or you can write it as a field resistance. Okay. Now come to the array. What is the array? Array is nothing but we already written in many cases armature resistance. And due to the armature, what will happen? One EMF is induced, that is your EG, that is your EMF induced across the armature. You can write, right? EMF induced across the armature. Now we'll the sound connections happen, just what I will do, I will mark out the point. Suppose this is the point A, this is the point B, and here you can mark it as a C and D. Here you can mark it here. That means all the parallel conditions, we know that the voltages are equal. That means, can I write here that VCD equal to VAB equal to VEF due to shunt connections. Okay. Now one by one we'll do. First, when I'm talking about the shunt connections, first I will calculate already 2 points. Already the equation number one, the current relations we already find out, and now we will find out the shunt current as well as the load current. Here you see, suppose VCD equal to, we written that VCD equal to VAB. Then what is the voltage drop across the CD? That is nothing but your ISH into RSH, right? Equal to your VAB. VAB means the voltage drop across the armature. Then here the generated EMF is EG, then minus IA RA minus VB. This is the overall things of the armature equations, or VAB you can write. Okay, this is the VAB, the right hand side, the left hand side is the VCB. Now you can easily calculate the shunt current. ISH nothing but equal to IEG minus IARA minus EB by RSH. You can mark it as equation number 2. Two questions already we found out, 1 and 2. Now come to the derivations of load current or armature current. We'll find out, right? You can say armature current. The next slide here. You see how to find out the armature current. Here I mentioned that points are A, B, here A, B, C, D, and E, F. Now we relate this VAB equal to VEF loads. Then if you will relate, then VAB means what we will do? The equation we will write, that is EG minus IA into RA minus VB equal to your VF, right? If you want to calculate only IA, that is nothing but EG minus EB minus EA equal to your IA into RA. Now you can easily calculate IA, EG is our Shunt mm, generator, and this is the number of equations. One, we got the equation that is your IA equal to ISX plus IA, first equation. Second equations we get that ISH nothing but your EG minus VB by RS, right? Now the third will get this. Then one, two, three. These three equations is dedicatedly applicable for this Shunt generator. Okay, and Shunt generator is one of the generator of self-excitation. When we will detail solve the problems, you will get more clarity on this. Okay. Now we will discuss about the applications. In this applications, the first process is electroplating that provides steady voltage and ideal for uniform metal depositions. If you are want to do the electroplating process, then you can use the Shunt generator. It's more and general lightings because as we use where the voltage regulation is critical for consistent illuminations because the Shunt generator the voltages are equal. Okay, and that's why where the many voltage fluctuations will occur in this type of conditions or voltage regulation. Many times the voltage you want to regulate many times because otherwise the lights are sometimes it is blown up, sometimes down. In that condition, what we will do, we can use the Shunt generators. And third one is to generate to provide excitation to the alternator because we need the uh, or we are using the excitation to excite the uh, alternators. That is also served as a field excitation sources in a large power stations like industries do have. These are the possible applications. More applications are there, but I presented only three. Okay, that is very important applications. Now come to the series generator or self excitation, another method. In series, the field winding and armature winding both are connected in series. That is nothing very difficult, it is very simple. The circuit diagram would illustrate first one thing you first see the current directions first. And our, and I know we know that armature winding the is this one and the red lines are field winding, the armature winding, the generated EMF is, EMF is generated. Due to the EMF generated, the armature current will flow and across this armature current direction will be like this. Then it will go, the current will like go like this. Again, it will go like this and it will be the return. Okay. And if load will connected, this is the incoming part. That means everywhere you are getting this armature current and these values are not changed, if not changed at all. If you are connecting here the load, you see, and this is your generated EMF, that the process, the current is going inside and the current is flowing like this. And everywhere you are getting the IA current, right? This is all about your series generator. It is not at all very difficult. Only you have to write the equation, and here we can write one point that is all point the current, armature current, load current as well as the field current is equal. This is you can put as a equation number one. And here why RAC I have written because your field is connected in series. That is nothing but your RAC means that is your series resistance or field resistance. Okay. Now if you apply KVL here, what is the current equation for TC? EG minus IA RA. If you consider the cross voltage drop minus A into E, IA into RAC equal to VL. It is very easy to calculate the IA current. That is EG minus VB minus EL equal to 0. IA into RA plus RAC. Now we can easily calculate your IA, that is VG by VG minus RA plus. This is very simple one. And from this you can understand IA. And you can, if you can compute the IA, then it definitely you can compute the IL and definitely all the process. All the, okay. Then this is self-study should move on. Series generator. Then series generator applications you will understand. Okay. And in these applications, one aspect you can understand that industrial and utility applications. Suppose you are in your arc welding, you need the high current, okay, for the operations. And it is series, then you can generate the high current. Okay, series arc lightning, and heavy duty power system also you can use. Another one is in battery charging system. We need the constant output voltage. That case also. Then in a railway and transportation, what happens is your railway and transportation also these generators are used. That is for field excitation in regenerative braking. What is the regenerative braking? I'm just giving it insight to this one. Suppose now people are using this electric vehicle. Okay, regenerative braking means they are also producing the power with the application of the brake. Because in vehicle means anytime we are applying the brakes to stop our vehicle. During the application of the brake, what will happen? The vehicle definitely will stop. But during the application of the vehicle, it can regenerate. Means the power it is consumed, that also few powers can be returned back to the bed. That is also possible through the series generators. Okay. These are the possible applications. People are also lot of places are also used to these things. But for the very interestingly, I want to tell you that in the industry sector as well as the locomotive means transportation or railways, now we're doing the more research about the series generators and the application. Now first we will discuss about the long shunt generator. It is a type of compound generator. And before going to the compound generator, what is the need of this one? That is, you see the another resistance is added across the armature that is completely different to the traditional what we discussed like the but why? Have to be just briefing the armature reactions. In armature reaction, what is this? In armature reactions, we understand that the effect of armature flux on main flux. Okay, then there is what will happen? There is suppose two pole machines, there is one north pole and south pole. What are happening in that? Detailed lecture is also given in the previous slides. What will happen when you will go to the previous lectures, then you can understand about the more detail about the armature reactions. But just I am briefing to understand this compound generator. What we studied that always from north pole to south pole the magnetic lines will go. That is nothing but and due to the magnetic line one flux is produced. Magnetic flux that is known as a field flux. Okay, the direction is like that. As one armature is present above this one, and due to what will happen due to the supply or any energization, what will the armature starts rotating. We are giving the prime mover at rotating. And armature having the two coils. Okay. Due to the two coils, what will happen? The armature flux will produce to the downward. Okay. And if the armature flux is produced, what will happen? Then it will oppose the field flux. then definitely if I will draw the phasor, then field flux direction is this one, and armature flux direction quadrature to this one, and its effect on the field flux we are studying, we are telling the armature reactions. And due to the armature reactions, what will happen? We know that there is a two axis. One is your polar axis. This is, you can say, the polar axis or D axis, and it is known as your Q axis, or you can mention it as a polar, and it is a geometrical neutral axis. Both are perpendicular to each other, right? And there is one magnetic neutral axis is there, and always it is lies on the same plane of the Q axis. And where the MNA will lie, there will be the, what will happen? The process we can connect V1 and V2. Now, due to the armature reactions, it will affect the field flux direction is not horizontal properly. It will be like this. Okay, this type of flux are come resultant flux. Then what to do? Due to this one, what will happen? This MNA position is changed to this position, suppose, and with an angle theta. Okay, that is the change in positions. And due to this one, what will happen? Even if we were giving turned off the supply voltage, what will happen? Your generator still some energy is there. Okay, means the generator voltage will not drop to zero at immediate impact due to this one. Then what will happen? There is a huge loss will happen, and as it is oppose the field flux, then definitely there is a reduction of field flux will happen. Then to avoid this one, the strategy we are using? We are adding another resistance which is series with the armature resistance. Okay, we discussed this matter in the interpole conditions also. In interpole also the same things we already discussed, that the connection is we are adding one resistance series with the armature, and same type is the compound generators. Don't be confused. Okay, both are equal. In interpole condition, what we understand that there is a, if I will draw here this space, what will happen? There is a, suppose north pole. This is the south pole, right? North and south. There is an armature is there, right? And there is two process, and we know that the current will enter at one side, and it will come outside another side. Then you just try to understand the point. We are adding one resistance. Okay. First, you see that if how the interpoles will be designed. There is suppose two pole machines. Another one pole intentionally we are creating across this one. That means we can thin plates we are connecting, and the winding will providing to this one, and it will also behave such a electromagnetic, right? Now, how will it do the current flow? You see the current flow when we are doing the winding, the current suppose entering to this side to the armature, then it will go to the armature. Then what will happen? The windings will happen across this metal. Then again it will come here, because any path we have to complete. This is the again current path, and it will do the current direction will go like this, current will flow like this, same current here, and it is the out. Suppose this is the A point, this is the B point. What is the main reason to add this resistance? When the current is flowing across this one, the armature will develop some EMF, and here the again the current will go to these conductors, that field conductors, but as it is connected in series, what will happen? It also generates some opposite EMFs. Okay, and as both we already drawn the field flux is this, okay, and armature flux is this, it will generate another opposite flux, that is your compensation flux. by which you see this phi C and phi A are opposite to each other. That means they will each other cancels, and only there is the field flux is there, and the effect of field flux only we are studying to generate the power or voltage. That's why it is a more advantageous as compared to the Shunt generator or series generator. Now we see the current directions here. Okay, in the current directions here when we are studying the same thing as it is flown in the sound generator, it is also produced, but here one additional resistance is added. You can see here, this is the additional resistance. Okay, you can put as it is connected in series, then to the armature you can put RAC, and here we know that there is some armature resistance is there, and this is sound connection, that is sound resistance, and all the parameters already defined. Now we'll go for the equation solving and calculate the sound current as well as series current. Now the next slide is this slide. You see the current direction is already given, and as it is connected in parallel, first we are naming as A, B, and C, D, and E. We know that in parallel connections that AB equal to BCD equal to BF. Then you can write also for your to avoid your confusion, VAB nothing but your armature voltage drop. Okay. Then BCD is nothing but your field. Okay. And BEF is nothing but your load voltage drop. These are the conditions. Okay. Now, step by step, we will do. First, we will take two voltages. Suppose VAB equal to VCD, we are considering. Then armature voltage, we will first the equation generated EMF minus IARA minus PB. We can keep minus IA into RAC. This factor is newly added. This factor is newly added in this system. In sound generator, this factor is not there. Okay. Okay, if you compare this both the equation, this factor is newly. VEF means that is your load voltage. Can if your load voltage, then how will you calculate the IA? IA is nothing but when we calculate that is your EG minus BB minus BL by A plus. Okay. Now we'll go to calculate because in the parallel circuit we know that another that is condition IA equal to ISH plus, right? This equation also we derived in something. Then we can find out easily ISH because now we will compare that VCD equal to VF. Then if VCD, that is the voltage drop across CD, that is ISH into RSH equal to VF. Then what is the ISH? ISH equal to VL by R. This is our equation number. You can give the equation number 1. This is the equation number 2. The equation number 3. All these conditions we are calculating the currents. Nothing much more difficult. But here what will happen? The one armature resistance is across the armature resistance one additional series resistance is added. Why it is called as a long shunt generator? Because you see the shunt resistance is connected or fully covered the armature. If it is not fully covered or half covered or this much only armature resistance it is covered, then it is in short shunt. That only we will discuss. Similar to the long shunt generator, short shunt generator is also designed, but there is little bit difference only. In long, what will happen? This resistance is completely cover the armature as well as the series resistance. But here in short shunt means it is only covering this armature resistance, right? Then come to the point, how will solve this one? You see, if you will see this armature part as well as the field part, then what will happen? Both are parallel to each other. And here, if we are difficult to distinguish this one, you mark this connection point only one. That is your A, suppose. Now the current IA is going towards or coming towards A. Then what will happen? There is at if you will stand at a point, there is two directions. One is your shunt current direction, another one is your series current directions, right? If these two currents are there, then definitely if I will stand at A, we know that KCL, the incoming current is equal to outgoing current. You can write here at point A what we are getting. The incoming current, what is the incoming? IA equal to VSH plus I. This we know from previously also we are solving this type of thing. We can mark it as equation number one. As all these things are connected in parallel, there is two relations you will see. First, I am just giving them naming. A, B, C, D, E, can put. Now we'll first take this armature is having two parts. One is AB as well as BC. Okay. Then first we will take the consider the small section of the armature. That is your I'm considering only VAB. If I'm considering only VAB, it is equal to your definitely your field voltage drop. You see, because the current is divided at the point of A. Then can I write VAB is equal to VMN, right? Now you write the equations of VAB. VAB is nothing but your EG minus IA into RA minus EB because voltage drop we are calculating equal to your VSH. Okay. In place of VSH also you can write down here EG minus IA into RA minus VB. You can write down this into RSH. Right? You mark it equation number two. Okay. Now another point we will discuss. The small part is over. VAB equal to VMN. Now we will consider the large part. What is that? BBC is equal to your, that VD, right? By looking. Then BBC means complete armature circuit will come to the picture. If it will coming to the picture, the complete armature circuit, then you see here that is the equation is EG minus IA into RA minus BB minus ISC into RAC equal to your C, right? Now the term is coming IARA. You mark it as equation number 3. But you just try to find out to the in this equation what are the common terms are coming. If I will move this one to right side, then EG minus IA minus BB equal to BL plus ISC into, right? Then in this equation, can I write if I will compare, this is the equation number 3, then if we will compare um, this equation 3 as well as equation and 2, then what we are getting, the another equation will come, that is your VL plus ISC into RAC equal to ISH into R. Any factor if it is given, then you can easily calculate the current. There is nothing difficult. ISH equal to VL plus ISC into RAC divided by your RAC. But you have to, during this type of problem, you have to remember, you have to write the all the equations like this, and you can easily, as per the parameter given, you can easily calculate all this. Okay, this is the sort generator. I think all the generator types we discussed and related to that, the current as well as armature current, field current, load current, all the voltages we calculated. That means after calculating all these things, now we try to solve some problems. And here I will solve very important 4 to 5 problems that each applicable for you. Okay, this is very important.